In this section, we're going to take a closer look at the periodic table. So with the periodic table, again, it is organized in groups, so the different columns, and mostly the columns have similar characteristics, similar types of reactivity. So we do have some videos that I've posted online that show you some examples of this reactivity. There's one on Mythbusters that actually deals with the alkali metals here. So the alkali metals are your first column. They are known as group 1. They have one electron in their outer orbital, and because that one electron is just kind of sitting out there chilling, they really just want to give it away. Okay, they want to that electron just wants to jump off of the atom and go on to any other atom that it can find. So they will readily lose that electron to form what's called +1 ions. So we're going to go more in depth into ions in the coming chapters. So this will be more important to come back to later to kind of understand that again. Okay, the reactivity increases as you go down the column. Okay, so again, hydrogen is something of a little odd man out, so it doesn't necessarily react the same way that everything else in its group does. But for the most part, as you go down the column, down the group here, you're going to get increased reactivity. Okay, so francium actually happens to be one of the two most reactive elements on the periodic table. Fluorine is actually the other. Okay, so francium and fluorine. So francium happens to be radioactive, so it's kind of rare. You don't really see it all that often. It is also incredibly explosive. So all of these elements, except for hydrogen again, react explosively with water. So when you put lithium in water, you're going to get some sparks. It's not going to be a whole lot. Sodium, depending on how much you use, you can actually get a small explosion. But once you get up to cesium, as you will see, actually I think they only use rubidium in the video with the Mythbusters, they actually blow up a bathtub with it. So, quite reactive. In fact, whenever you have pure element of any of these elements, especially the ones lower down in the group, they are so good at reacting with water that if it's even the slightest bit humid, they will react with the water in the air. So in order to store these elements, they actually have to be stored in oil and basically vacuum sealed in that oil. That way they don't come in contact with any water that they can react with. Next up, we have the alkaline earth metals. So you had the alkali metals, and now you have the alkaline earth. Okay, the way I remember the order is that alkali is just one word, and then alkaline earth is 2. So you get group 1 and then group 2. Okay, so these you might recognize a couple, magnesium, calcium, radium. Okay, they have 2 electrons in their outer orbital, and they will readily form +2 ions. They are relatively reactive, though nowhere close to the reactivity that you find in the alkali metals. Next up, we have the transition metals. So the transition metals are kind of weird. You'll notice that they don't necessarily seem to fit in with the rest of the periodic table. They're kind of lower down a little bit. These metals actually will form multiple different ions. Okay, so if you notice, you can see some of them are actually marked on the right side of each of these little boxes. The most common ones are marked in bold. Okay. Oftentimes you will see some, like molybdenum, that have multiple different ions that they can form multiple different charges. Okay, so transition metals are really kind of strange when you get down to it. So some elements can form multiple charges. These, because they are metals, they are malleable, ductile, good conductors of heat, and good conductors of electricity. Okay, so you will probably recognize several of these. We have titanium, zirconium you might recognize. Then we've got manganese, iron, cobalt, nickel, copper, zinc, silver, gold, platinum, okay, and then mercury. Mercury is a very strange metal. We'll get into that a little bit later, but mercury is actually responsible for what's known as Mad Hatter syndrome. So if you've ever watched Alice in Wonderland, or you know that story in the Mad Hatter, that was actually a thing several decades ago, well, maybe a century ago. They used to use felt to make hats, and they would kind of cure the felt using mercury. Well, turns out mercury, especially in its pure form, is incredibly toxic and can actually leach through the skin. So all of these hatters that were using mercury to make their hats were basically getting mercury poisoning. And one of the symptoms of mercury poisoning is insanity. So, hence Mad Hatter syndrome. They also used to use mercury in like teeth fillings. Don't ask me why. I wouldn't necessarily think that it would be a good metal for that anyway, but yeah, if your tooth filling falls out and it's made of mercury, that's going to be fun. Again, probably the most common use of mercury that we know of today is used to be used in thermometers. They have since kind of phased those out, but if you ever find a glass thermometer that's got a silver liquid in it, that would be a mercury thermometer. Again, mercury is a liquid metal. Okay, it's liquid at room temperature. It's one of two elements that is actually liquid at room temperature. And it tends to form little beads whenever it's like on a counter or something like that. So it's very obviously not a solid, but it does bead up really well. So mercury's kind of interesting. You might have heard of it because it used to be used and sometimes is still used in vaccinations as a preservative, but in that case it is safe because it is in a compound. Okay, so just because the element itself on its own is toxic doesn't mean that every compound it's in will be toxic. They don't really use mercury as a preservative or those mercury compounds anymore, simply because of all of the kind of uproar about it. So, yeah, even though there's no reason for it not to be in the vaccinations. Anyway. Alright, so you also have some other metals. They are to the right of the transition metals. Okay, so they are kind of, basically you've got this little stepladder thing going on here. So they are solid metals under standard conditions, so at room temperature, all of that kind of stuff. Again, they have the standard properties of metals, so you might recognize aluminum, tin, lead. Okay, there's also bismuth. Kind of a weird one again. Gallium is actually pretty interesting. It is solid at room temperature, but if you get just above room temperature, it'll melt. So if you ever see kind of like a silver spoon that melts in hot water, or like somebody gives you a piece of metal and it melts in your hand, that is gallium. Okay, so those videos were making the rounds on YouTube a little while ago. I wouldn't necessarily recommend holding gallium in your bare hand, but, you know, it still looks cool. So they generally have high densities, and then aluminum, gallium, indium, and thallium. These four right here in this column will form +3 ions, and then tin and lead like to form either +4 or -4, so they're kind of weird. And then bismuth likes to form -3 ions. Okay, so again, it really depends on what periodic table you're looking at as to whether or not polonium is considered to be a metalloid or a metal. Okay, in this case, it's not considered a metal, so it's not on here, but we'll see it here and under the metalloids. So metalloids, you're going to go to boron, and then it's basically a step ladder going down. Okay, so metalloids, again, will look like metals, but they have several non-metal behaviors. Okay, so generally they are shiny, brittle solids, and they are semiconductors, so they are relatively good conductors, but they're not that great at it. Okay, so again, as we go across the periodic table here, we've got boron up first. It likes to form +3 ions. Next up, we've got silicon and germanium. They like to form either +4 or -4 ions. Then we have arsenic and antimony. They like to form -3 ions. Arsenic is kind of interesting. It is incredibly toxic to humans, so it is recognized as a poison. And if you're a crime scene or crime show fan, like CSI or anything like that, oftentimes they will talk about arsenic poisoning, or you'll get an episode here or there where they do. Arsenic, well, in high doses it's toxic, but in lower doses it can actually be found in almonds. So interesting thing, almonds, I'm not saying that almonds are poisonous, okay, but people who eat more almonds have actually been shown to have a higher tolerance to arsenic. So it's something that you can build up at least something of a tolerance to, but not necessarily that that would protect you from like a major dose of arsenic or anything. And then finally we have tellurium and polonium. They like to form -2 charges. Okay. Alright, finally we run into our nonmetals. Okay. You'll notice that this is slightly, well, this is fewer elements considered nonmetals than we looked at in the last section. It's because the next column actually has a very specific name, so we'll get to that in a second. Nonmetals, again, includes hydrogen. Okay, so it kind of likes to act like carbon, nitrogen, oxygen in a lot of ways. So it gets included in the nonmetals here. So we have hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. So most of those are you might have heard of, probably heard of before. Selenium might be the only one that you haven't really heard of. These are poor conductors. Okay. They are brittle solids if they are found as a solid, though oftentimes they will be found as gases. They have little or no metallic luster, so no like shininess to them. They are dull. Hydrogen likes to form +1 ions. Carbon can form plus or -4. Nitrogen and phosphorus like to form -3 ions. And then oxygen, sulfur, and selenium like to form -2 ions. Okay. A lot of times you will find several of these, well actually 3 of them, hydrogen, nitrogen, and oxygen, as what are known as diatomic gases. Basically, diatomic just means it's 2 atoms of the same element are bonded together. So like H2, hydrogen gas, N2, nitrogen gas, or O2, just oxygen. That's what you breathe in. Okay. Alright, and then we are actually going to stop here for this video and then pick up right here for the next part.